Did you know that electric motors actually chew through almost half of all the electricity generated globally? It's wild when you think about it. But it brings up a huge question. How do we precisely control these massive mechanical beasts, all while saving energy and keeping them from literally tearing themselves apart when they start up? Well, welcome to this explainer where we unpack VFD Mastery, the complete industrial automation guide. Today we're zooming in on the variable frequency drive, or VFD. You can really think of it as the ultimate brain of the modern factory. By the end of this, you're going to see exactly how this incredible device takes raw electricity and transforms it into intelligent, highly efficient mechanical power.
So here is our roadmap for today's explainer. We're going to start with Part 1, the Smart Motor Controller. Then we'll move to Part 2, Inside the VFD Journey. Next is Part 3, the Math Behind Speed, followed by Part 4, Industrial Benefits and Faults. And we'll wrap the whole thing up with Part 5, Automation and Future Tech. Let's get right into it.
Part 1, the Smart Motor Controller, upgrading industrial power.
To truly appreciate what a VFD does, we kind of have to look at the massive industrial problem it was built to solve, which is wasted energy and zero speed control. Think of the AC motor as the pure muscle of a factory. Now, for decades, industries just used a basic direct starter method. When you flip that switch, the motor instantly jolts to full, constant speed. It is literally like driving a car with your foot permanently mashing the gas pedal to the floor. It causes huge energy waste and a ton of mechanical stress. But enter the modern VFD approach. A VFD gives us variable speed. It allows the motor to wake up smoothly and run at the exact speed required for the job, making the entire operation highly energy efficient. Moving on to Part 2, Inside the VFD Journey, Following the Current. Let's shrink ourselves down for a second and trace the actual path of raw electrical power as it travels through the drive. It takes a very specific step-by-step journey. We start at the incoming AC power supply, which feeds directly into the rectifier. From there, that power flows into the DC bus, then it pushes through the IGBT inverter before finally reaching the AC motor as a totally customized power wave. Let's look under the hood at each of these internal organs.
First up, we hit the rectifier. You can visualize this as the system's intake valve. See, the power grid gives us alternating current, or AC, but the VFD actually needs to break this down so it can completely rebuild it later on. So the rectifier converts that incoming AC power into direct current, or DC. It pulls this off using a diode bridge, essentially acting as a full-wave rectifier that forces the electricity to flow in just one specific direction.
Next up, the power surges into the DC bus. Now, when electricity first comes out of that rectifier, it's actually pretty choppy, so the DC bus acts as both a reservoir and a filter. It utilizes a heavy-duty capacitor bank for ripple filtering and energy storage. It basically irons out all those rough electrical ripples so the power becomes perfectly clean and stable. What we're left with is a smooth DC supply that is totally prepped for the next and most crucial step.
And that brings us to the inverter. This is the true brain of the operation. The inverter takes all that smooth DC power and utilizes components called IGBTs. Just think of IGBTs as ultra-fast, incredibly heavy-duty electronic switches. It combines these with a technique called pulse width modulation, or PWM. By rapidly firing these switches on and off in very precise patterns, the inverter literally synthesizes a brand new, completely artificial AC wave with a variable voltage and frequency. And it's this custom wave that finally gets sent out to the motor.
Let's jump into Part 3, the math behind speed, controlling the RPM.
Okay, so we know how the VFD generates this custom electrical frequency. But how does that actually translate to physical movement? Well, it all comes down to a super elegant universal formula. Speed equals 120 times frequency divided by the number of poles in the motor. Now, because the number of poles inside a given motor is physically fixed when it's manufactured, the only possible way to change its rotational speed is to change the electrical frequency. This equation is exactly how the VFD works its magic. By tweaking the frequency at that inverter stage, it has direct, absolute control over the motor's RPM.
Let me give you a concrete example to make this super clear. Let's say your VFD feeds a standard 50 Hz frequency into the motor. The motor's going to spin at its normal high speed, right? But if you dive into the VFD parameters and dial that output down to 20 Hz, the motor speed drops perfectly in proportion. You get total dial-in control without sacrificing your torque. In industrial processes, that level of control is an absolute game changer.
Part 4, Industrial Benefits and Faults, Real-World Application.
We've looked at the microscopic level, so let's zoom back out to the wider factory floor.
Out in the real world, whether we're talking about massive water pumps, HVAC systems, or heavy cement plants, the practical advantages of a VFD are huge. First and foremost, you get massive energy savings, which goes straight to the bottom line by lowering electricity bills. But it's also about longevity. The VFD gives you a soft start and a soft stop. So instead of violently jerking awake, the motor gently ramps up. That means way less mechanical wear and tear. Add in the precise speed control and dedicated motor protection, and you are guaranteeing a much longer motor life.
Now, as we all know, factories can be really harsh environments, and things do go wrong. But the VFD acts like a highly sensitive bodyguard for your equipment. If there's a sudden overvoltage or undervoltage spike from the main grid, the VFD instantly trips to save the motor. It is constantly monitoring to detect overcurrent, a motor overload, a dangerous ground fault, or a phase loss. When something happens, a technician can just walk right up to the VFD display, read the fault code, and know exactly what disaster the drive just avoided.
Finally, Part 5, Automation and Future Tech, the macro view.
Today, a VFD is almost never just sitting out there as an isolated, standalone device. It's a node in a much larger conversation. Data is constantly flowing across the modern factory floor. A programmable logic controller, or PLC, fires off commands via industrial networks like Modbus or Ethernet, down to the VFD. The VFD then drives the motor to do the physical work and immediately reports all of its performance data right back up the chain to a SCADA monitoring system. This creates a centralized hub where an operator sitting in a control room, maybe even miles away, can see exactly what that motor is doing second by second.
And looking slightly ahead, the future of this technology is incredibly exciting. We are moving deep into the era of Industry 4.0. We're already seeing AI-based motor control that can actually learn specific process patterns. By combining the industrial Internet of Things with cloud monitoring, we unlock predictive maintenance. That means the VFD data can literally warn you that a motor bearing is wearing out weeks before it actually breaks.
So, what's the big takeaway here? The VFD is the critical bridge between raw, untamed electrical power and intelligent, efficient mechanical work. It truly is the ultimate automation device for precise speed control, massive energy savings, and superior factory efficiency. Honestly, if you're anywhere in the maintenance, engineering, or automation space, mastering the VFD isn't just helpful, it's absolutely essential.
We want to wrap up this explainer by giving a quick shout out to DEVI Automation Solutions, who are featured in today's source material. They offer some really comprehensive industrial services, doing everything from PLC programming and SCADA systems to AI, smart agriculture, and even solar energy solutions. If you found this breakdown on industrial automation valuable, make sure to like, comment, and subscribe for more deep dives. But before you click away, I want you to think about your own facility for a second. Where is your biggest, most wasteful energy drain, and how might a VFD completely optimize it? Think about it. Thanks for hanging out with me on this explainer, and keep learning.